Okay, so you wanted to explore some alternative quantum mechanics ideas,
Mm-hmm.
specifically Sir Roger Penrose.
Right.
And I've got to say, digging into this stuff, it's pretty wild. You
Yeah.
know, we're talking about challenging the very foundation of how we understand reality, the quantum world.
It's really questioning the fundamentals. And
Mhm.
I think what makes it so interesting with Penrose is that this isn't just
Mm.
someone who's, coming up with these radical ideas without
Yeah.
any sort of background. I mean, this is a Nobel laureate
Exactly.
who revolutionized our understanding of black holes.
Yeah.
And when someone like that says that standard quantum mechanics is wrong,
Yeah.
you kind of have to at least listen.
You sit up and pay attention.
Right.
Before we get into all of that, why he thinks quantum mechanics is wrong, what he proposes instead,
Sure.
maybe we should do like a super fast review of
Yes.
standard quantum mechanics,
Yeah.
just so we're all on the same page. So, imagine the quantum world as like a stage, right?
Okay.
Where these particles, they can exist in multiple states at the same time.
Right.
That's superposition, right?
Yeah, like a spinning coin that's both heads and tails
Okay.
at the same time.
Yeah.
Until you stop it and force it to be one or the other.
Right.
It's kind of like when you make a measurement in quantum mechanics.
Okay.
And that act of observing it or measuring it forces the particle to choose a single state.
Okay.
And that's what they call, wave function collapse.
Right. Wave function collapse.
Wave function collapse.
So I think I'm with you so far.
Okay.
So where does he disagree?
He takes issue with this idea
Okay.
that observation or even like consciousness itself
Right.
plays a role in collapsing the wave function. And he uses this example of a probe observing weather on a distant planet.
Okay.
And, according to standard quantum mechanics,
Right.
our observation of what that probe is seeing
Yeah.
would somehow instantly affect the state of the weather on that planet,
Really?
which,
With light years away.
right.
Wow.
And he's saying that's absurd.
Yeah, I can see why he would say that. That's a bit of a stretch.
It doesn't make sense to him that our consciousness here
Yeah.
could have that kind of immediate impact on something so far away.
Right. Okay, so if our consciousness isn't doing it, what is?
He proposes that there's something else at play,
Okay.
like a yet undiscovered mechanism within the laws of physics that governs this collapse.
Okay.
And he believes that it's fundamentally tied to gravity,
Okay.
and that we need to rethink how gravity is integrated with quantum mechanics.
So he's not just saying that we need to quantize gravity,
Right.
which is bringing gravity into the quantum framework.
That's right.
He's saying something far more radical.
Much more radical.
Like a complete redo. Like what? How?
Yeah, like a fundamental overhaul
Yeah.
of how we understand gravity at the quantum level. And you won't believe where this leads him.
Where does it lead him?
To a potential connection between quantum mechanics and consciousness.
All right, now you've got my attention.
Okay.
How do we get from revising gravity to consciousness?
Well, his argument is that consciousness itself arises from quantum processes happening in the brain,
Oh, okay.
not the other way around.
So instead of us, like our consciousness influencing the quantum world, it's the quantum world that's giving us consciousness.
Exactly.
That's a pretty wild idea.
It is wild, and this is where things get even more interesting.
Okay.
Penrose, along with his collaborator Stuart Hameroff,
Okay.
suggests that these quantum processes might be taking place within microtubules.
Microtubules.
Yeah.
I'm lost. What are microtubules?
So think of them like tiny scaffolding structures inside our cells.
Inside our cells.
Yeah, and Hameroff, who's an anesthesiologist, proposed that these microtubules could be the perfect environment
Okay.
for these delicate quantum processes to occur.
So they're like little...
Almost like the brain's quantum computers.
Hold on. Tiny quantum computers in our brains.
Potentially.
And that's where consciousness comes from.
That's the idea.
It's pretty out there.
I know, right? But before you dismiss it as pure science fiction,
Yep.
it's worth noting that there's a growing body of evidence
Okay.
that suggests that quantum phenomena might actually play a role in biological systems.
Interesting.
We're a long way from proving a definitive link to consciousness.
Okay.
But it's a possibility that researchers are taking seriously.
So we've got quantum processes potentially happening in our brains,
Mm-hmm.
possibly within these things called microtubules.
Yeah.
All this is tied to Penrose's critique of quantum mechanics.
Right.
how the wave function collapses. I think I'm following so far.
Okay, good.
But I got a feeling this is just the tip of the iceberg.
You're exactly right.
Yeah.
To really understand where Penrose is coming from,
Okay.
we need to zoom out and look at the bigger picture
Okay.
of quantum mechanics interpretations.
Yeah.
Because believe it or not,
Yeah.
there are many different ways
Really?
to interpret what's happening
Wow.
in the quantum world, and Penrose's view is just one of them.
Okay. It's like we're looking at a map,
Okay.
right?
Right.
And we can see all the landmarks, all the different routes.
Yeah.
But there are different ways to understand how to
Yeah.
read that map, you know?
Totally.
Different interpretations.
Yeah, and in the case of quantum mechanics,
Right.
it's like these different interpretations give us a framework
Okay.
for wrapping our heads around these really bizarre quantum phenomena.
Yeah.
You know, like we were talking about before.
Right.
You found that document that summarizes some of these different interpretations.
Yeah.
And it really is a whole spectrum of ideas.
It is.
From the Copenhagen interpretation,
Right.
which a lot of people know,
Yeah.
to some really out there concepts.
Yeah.
Like the many worlds interpretation.
Right. The many worlds interpretation.
There's even one called QBism, which
QBism. Yeah.
I don't even know if
That one,
that's like a whole other.
I couldn't wrap my head around that one.
Yeah, exactly.
That,
But the many worlds one,
the many worlds. I remember that one.
at least you can't like,
That's the one where,
you can't kind of picture it.
yeah, every time there's a quantum measurement,
Uh-huh.
the universe splits
Yeah.
into multiple universes.
Right, for every possible outcome.
It's a lot of universes.
Yeah, as you can imagine, it's a very controversial interpretation.
Right.
But the point is that there are many different ways to try to make sense
Okay.
of what we're seeing in the quantum world.
Okay. I get it. So,
And Penrose,
yeah.
with his ideas about,
Right.
the wave function collapse being an objective process,
Mm-hmm.
he falls under the umbrella of what are called objective collapse theories.
Okay. Objective collapse theories. Now break that down for me.
What's that?
What makes those different
Okay.
from
so
like the Copenhagen interpretation?
the Copenhagen interpretation puts a lot of emphasis on the role of the observer.
Right. Right.
We were talking about that whole debate.
Right. Does it take a conscious observer to collapse to
Exactly.
make the decision?
Yeah, objective collapse theories basically say, nope, it's not about us.
Okay.
They propose that this wave function collapse.
Yeah.
It's a real physical process
Yeah.
governed by a mechanism that doesn't care about us.
So it's not our observation that's forcing the particle to choose,
Thus,
like the coin flip.
yeah, like there's something else. It's like built into reality itself
It's its own thing.
that dictates how and when this collapse happens.
Okay, so it's not us, but there's something,
There's something else there.
there's some other mechanism.
And this is where it gets even more interesting
Okay.
because different objective collapse theories
Okay.
have different ideas about what drives this mechanism.
Okay.
Some propose it's totally random,
Okay.
like a cosmic coin flip.
Just boom.
Others suggest it might be these non-computable processes.
Non-computable.
Yeah,
My brain hurts.
it's a lot.
What does that even mean, non-computable?
So basically,
Yeah.
these theories are suggesting that there might be an inherent unpredictability
Huh.
to reality itself.
Okay.
Even if we had, like, the most powerful computer imaginable, we could never predict the outcome of these processes.
So randomness, non-computable, we're just trading one mystery for another, right?
Yeah, pretty much.
But Penrose, he brings it back to consciousness.
He does. He ties it all back together.
Somehow.
He's not saying that our thoughts,
Right.
like, directly control quantum events.
Right.
It's way more nuanced than that.
Okay.
His idea is that consciousness arises from these fundamental quantum processes
Okay.
that are happening at the deepest levels of our brains.
So it's not that our minds are influencing the quantum world. It's that the quantum world is somehow influencing our minds. So it's like our brains are tapping into this other level of reality,
Yeah.
this quantum realm where all the rules go out the window.
Right.
And that's what's creating our experience of consciousness.
Yeah, it's a pretty profound idea when you think about it.
It really is. And I have to say,
Like, it challenges our whole notion of
Why?
what the world even is.
it is, but there's a part of me, I think it's really exciting.
Oh, absolutely. It's mind-blowing.
Because, it makes you think. And that's what this is all about, right?
Exactly.
And this brings us back to Penrose's initial critique of quantum mechanics.
Yeah.
He doesn't want to just say, oh, it's incomplete. He wants to completely redo it.
He wants to find a new way to understand it.
Yeah.
One that includes consciousness.
Right, exactly. That's the key.
Yeah.
He's saying you can't ignore consciousness.
It's got to be part of the equation.
It's got to be in there, which is a big statement.
It's huge, especially for physics.
Because so many physicists are like, no, we don't talk about consciousness.
Yeah, it's like the forbidden zone.
It's taboo.
Yeah.
But if Penrose is right, and consciousness is this fundamental part of reality,
it really makes you wonder.
what does that even mean?
Yeah, like what does it mean to be conscious?
Right.
What about artificial intelligence?
Exactly. Like if our brains are doing these crazy quantum computations.
Right. Can we replicate that?
Can you program that?
Yeah.
Can a machine ever be conscious?
Now, those are the big questions.
That's a whole other deep dive.
Exactly. And this is where physics meets philosophy.
It really does.
And it makes you question what it means to be human.
Wow. So I think we've gone from the very, very small
The subatomic.
to the, our very existence.
The nature of reality.
Yeah.
Pretty big leap.
That's a big jump. And on that note,
I think we've done enough brain bending for one day.
I think so. Thanks for joining me on this deep dive.
It's been a pleasure as always.
It's been incredible. I've learned so much.
Me too. It's amazing what you can find when you start digging into these topics.
It really is. All right, everyone. Until next time.
Take care.